All right. Okay. Sorry about all this morning, everyone. So I'll wait for some folks to come back and we'll see. All right, so I should be good for a while, at least until hey Nico, sorry about all that this morning. So I think that's 3 streams to get 1 stream going. So all right, it dawned on me that this is what we needed to check for. So I started to derive a solution for this. So basically, it dawned on me that 45 is divisible by 3. Then I divide this by 3 again, and I get 5, and then I divide this by 3 again, and then, okay, then I have a problem. So it dawned on me that at each step, I need to check and make sure that it is evenly divisible by 3, because if it's not evenly divisible by 3, it can't be a power of 3. And then the other caveat is it needs to divide down to 1. So when I get to 3 and I divide by 3, I should always get 1. So that's what kind of power of 3. So I take in, and I think I showed you that this solution was pretty efficient, that I was able to get this to be in the top 5 percentile and the top 10 percentile of memory. So that made me feel pretty good when I did this challenge, and I think I have it right in the title. It's challenge 326. So basically, we need to go through and we need to solve, not that, this one over here. Pull this out. And yeah, there's only what, 10% out of the 2 million that have been accepted. So I mean, I thought that was really quite good. So if we think about it, so this is the way I did it. So we want to get down to 3. And we don't need to check and see if 2 divisible is divisible by 3. We don't even need to check it. So that's when it dawned on me that how I needed to start to devise this algorithm. Let's see. So I think what I first started was I started with this. So while true, let's kind of go through all of them. Then if n modulo 3 equals 0, so I'm literally going to do what I did here over and over and over again. And I'll show you a very efficient way to do it. And it really helps. It really helps speed up the code. So if n, let's start with 81, and then we'll check 80. So n equals n divided by 3. So again, this is completely legal. So then n is now 27. So then I go again. N is 9. wait a second. Okay. So then I go again, and now n is 3. Cool. So now if I do n equals 80, let's see what happens. This is literally what I did. So n is, so boom. It would cancel, it would stop right here. And I would not need to divide all the way down because basically I'm checking and then I'm reassigning. And then I'll show you this also. And we can also increment. This is completely legal in Python as well. You know how we increment and decrement? Well, it also works for divisors. So let's go back to 81. N equals 81. And then I go in. Just like so. And then what's in? 9. One more. Boom and boom. So, only if and let's see. Else break if, let's see, in what I do equals 3. And then continue, else return false. And then if I come down here, if this continues to go through, so I'm making this work. Return true. All right, so now let's check a couple of powers of 3s. Print power of 3. Because we know, and there's a caveat that I ran into that I accidentally solved that I didn't mean to. So we know this should pass, and we know we had a problem with 45 last time. So I hope Vinky ends up joining us today. I got a little bit of a problem with this. Sorry, we were working on my computer last night trying to get everything set back up. All right, so, all right, false and false. Well, that is not good because this should be true. And let's get 27 and 45. 45, comma. So we can keep up with this. So this is where I started. Okay, so these are both one's correct, one's not correct. So all right. So what did I, let's see if I can remember what I did next. I tried to make notes of this process. And then that dawned on me. What was next? So then I needed to change this to while n greater than or equal to 3. Because we are going to have an issue here in a minute. Okay. Because, again, to remind you, when we get down to 2, because this should, and also, let's see, I also liked to do this right here so I could see where, because right now with this loop, I did not know where and how everything else was going. So we could go back and change this. So I was having if, true. So let's get rid of this and let's put this back to true. I forgot this step. All right, so 1, 2, 3. And then I was having this hit else. And that's when it dawned on me that I was getting too many else's. So n greater than equal to 3. Because I want this to be, I want to get down to this last step and have this be, I think programmers should know more than one language. Each language is made of something special. I agree with that. Vinky, how are you doing today? And we're going through the solve of, because you had a very good point and I dismissed it too quickly. And the power of 3. So we need to loop through, and right now we're decrementing. So let's kind of go back a step. So we're decrementing through, and we're basically taking in the number and dividing it by 3 over and over and over again. And if it is not evenly divisible by 3, then it automatically fails, and it can't. But we need to do one little caveat because it took me a minute to work on this. So basically, the last time through it has to be 3, right? So we have this working here. Let's try 81. Because there is one little problem. 81 and 81. And let's come through here. All right, now I'm going to show you the one that I think this fails on. So we're good all the way till here. But 1. And this took me forever to, and now I just kind of just believe it. Oh, wait a second. I didn't think that captured this. Do I get 0? Oh, that's right, because I get a false positive here with 0. Nope. So 1 passes, which is correct, but I think then it also passes with 0. And I get false. Or I get a true and it should be false. Yep. Okay. So here we are. Because you can't find an exponent. So if you take 3 and you raise it to the power of, take 3, raise it to the power of 0. That's not very superscript. 0, you get 1. I've just come to terms with this. Mathematically, I don't get why that is. I guess it's still because you have one set. I can't remember. Do not hold me to the math on this. But 0, to get an answer of 0, there is no x that can get you to 0. I don't think a negative exponent. What does a negative exponent of 3 look like? -1. Yeah, about speaking ask 0 should be 1. Bingo. So -1. So is that a? We're not going to worry about negative exponents right now, but right now, so we need to deal with this. So we are really close with this, but it's not accurate. So if n equals 1, return true, return false. All right, so now let's try this again. And this will do it. Bingo. All right, so this caveat handles this. So basically, we're going through, and it's handling also 1, because I fell backwards into solving this for, let's see, so 20 divided by 0.2. Okay. You want me to do that, Nico? So what I accidentally fell backwards into this. I did not program this on purpose to capture this. I don't know the term for decrementing with division in Python, so don't hold me to this. And yeah, I have this continue in here to kind of speed this up. And let's go through here. And I showed boom, boom, boom. So I showed this solution earlier. I got rid of the continue. I wonder if I put the continue back in, if it speeds it up some more. Because then it's not running through here and it's stopping. Let's see. That slowed it down? Interesting. Let me hit submit again. Let me get rid of the continue. But it ate up more memory. No way. Okay. That I do not understand. Let me go back. So what I really want to kind of try to do. I want to see something. This is interesting to me. This is not the same speed, and it's not the... Okay. But what I really want to try to bring your attention to is this was on accident. I did not program this to grab here. What I was doing was, in my head, was going through the... let me get back here to chat. Let's see. Shouldn't it be 2 or even floor division might work? Oh, you guys looking at that problem? Okay. Right. Because we had 45 divided by 3, 15 divided by 3, which is still... It's still divisible, but then when we get to here and we divide one more, we get 1666. So then it halts and hits else and returns false. So we run through and we do 3 divisions and then we get bingo. 5 is not divisible by 3 evenly. So how I inadvertently, I do not want you to think that I thought about this explicitly. I was coming through here, and if it wasn't a 1, because basically it was this. And actually, I want to check and see. Did I inadvertently? Okay. I did not know if because I wasn't handling the float, because it didn't matter to me, because an int without and a float without zeros, it's Python handles that fine. So what I did is, in my head, but I realized that because I wanted this to be here equal to 3 divided by 3 is 1, that means it is a power. So return true, and so on and so forth. So then I think I was like, well, wait a second. And I was like, that's redundant. And then I got rid of here. And then when I got rid of this, I wasn't failing. So 3 to the exponent of 0. Because you can have an exponent with the power of 3. So basically it's like find all... It's kind of like an inverse or a handshake relationship of check and make sure if this could be an exponent of, and it's almost like, I guess a variation of this problem would be return true and what exponent of a power of 3, of a multiple of 3 of this. So if we got 43, it would be we could do a counter right here. And to find this out, it would be 1, 2, 3. Is it 4? One, 2, 3, 4. What am I missing? Oh, duh. 5. Okay. So 3 to the power of 5 is 243. Is that still in frame? Or can you still see me? Okay. You can make a website for you and host it. No, I'm not interested in having anything like that. Because actually I tried to get the domain name Python Basics and I think it was already grabbed up. So if it's not going to be that, I don't really have any interest, and I wouldn't even begin to know what content to put on it, and then managing that right now, and especially at this time with me trying to find another job, I do not need another problem. But I appreciate the offer, Nico. I really do. Let's see. All right. What else do we want to cover today? Because I know this stream has already been really, really, really weird. Well, let's see where we are. And just to show you, you always want to make sure you understand your paths of how everything is going. So because I had all of this here, and I wanted to make sure that I understood how many, because we did this last time when we first started. I think I just did while true. So I was getting 27 to come through here, and let's see, one more. I was getting 27 to come through. Let's see. What does Venki got? Venki always got the good stuff. A to the power of 0 is equal to A power of 3 minus 3. Hang on. Stuff is behind the... And then A... Oh, equivalent. Okay. Which is 1. I think I gotcha. Okay, so you're helping me go through why, because you're dividing it by. Okay. So you're basically doing the proof of. So if you look into chat of what Binky's doing for me to remind me of the math. So A to the power of 0 is 1. So it's the equivalent of this right here. And no. Let's start over. So you have, whoops. Because power of 1, 3 is the same as 3, 1 minus 1. So then 3 to the power of 0 is 1, because 3 divided by 3 is 1. Bingo. Great explanation, Vinky. Hey, Dax, how are you doing? So we went through and we solved our problem yesterday. It dawned on me last night after I took care of some stuff, and it was driving me nuts. So basically, here's our solution. But overall, we're iterating through, because at first I was like, wait a minute, can I make this a recursion problem? And I'm not super great at recursion, and there probably is a way to have this be a recursion problem. So basically, it is summed up as divide by 3 until you get to 1, and continue if it's evenly divisible by 3. And if you continue doing that and it gets to 1, then it's a power of 3. If at any point, let's do 80. If at any point you get through and you have a remainder, stop. It is not a power of 3. So, and I was just discussing how I fell backwards into this solution. because I toyed around with this while for a minute, and then I tried to get fancy, greater than 0, and basically this down here envisioned in my head was when I got to 3, if it was divisible by 3. Then, because I think what I did was basically 3 times 3 times 3 times 4. Not times 40 times 4. Then it was like if we were to get 108. So we would get to here and we'd be, I guess it would fail. I guess it would fail here. So like completely, I inadvertently did this, had this test here because my math was so bad that this would have caught this right here. So that's why I wanted to point out that I fell backwards into it, not actually programming. So you could actually come up here and do this first, and I wonder if it would speed it up. I wonder actually, because I was also showing everyone, not to show off, but just that when you think through a problem, even if you're doing brute force adjacent, because I'm having to go through, but I'm also checking every time, can I shorten it? Can I shorten this a little bit? But my solution was in the top 5% for runtime and in the top 10% for memory. So I just want to highlight, is there a way that you can speed it up? And sometimes you will fall backwards into it. Let's toy around with this. See if this speeds it up. That's not here. That's not what I wanted to do. Let's come here. And let's move this here. Let's see if this passes everything. All right. All right, and let's see if this runs and passes. Okay, so return false. So now I have, so that, I'll have to work on that. I guess we could sit here and do this. Because I was trying to think about optimization. Because I have multiple. Do I need continue? Wait a minute. Where did I get rid of continue? Let's see if continue makes it slower or faster. I don't need to highlight that. Sorry. Was thinking about runtime 20. Oh, because it's only those 4 solutions. And this is testing. I wish it only tells you how many there are that it tests if you fail. I wish it told you. It's like 21. It's like 2100, 2140. And it was that was when I found out I was failing on, I think, 2 of them with, yeah. I'm trying to remember which one. I haven't looked at chat in a minute. Anybody have? Okay. All right, so there's something. Yeah, so see here, I had these. So I knew it passed 0, but then this 1, I was getting false, and because I took this out and I didn't realize, and I was missing, I think I was failing 2 of the last. It's like I was passing 1137 or something like that. Actually, let's yeah, I can delete this. Let's see how many we get and we miss. Because I'll miss the 1, Yep, missed one, and then it'll show me up here. Oh, wait, okay. 21,040 tests. And I pass all but one, which is then testing one. And then I do Control Z and I get it and I run. And you can also then add your test case right here to this. So if you do not know that, you can add test case so you don't have to keep submitting, because I don't know if that affects your score on Leetcode. Man, that is awful yellow. Let me get this out of here and see if yeah, we added this back. So now I'm at 79. All right, let me get over here and let's see. That's a little bit better. Okay, let me get back to chat. Okay, so is there anything about this that I need to address? Because we finally had some folks come in and drop in and come out. But hey, if you've not hit the like button, do me a favor and hit that. And if you're super brand new, I'd love to know what time zone you're in. You don't have to tell me where you are. Just tell me the time where you are. It just kind of gives me an idea. And if you've not joined Discord, super great place to send code, ask questions, kind of like, hey, can somebody validate this for me? Hey, I don't see where this is bugging, things like that. And it's a lot easier to share code, and it's you're going to get you can get more of a response from me, and also in Discord, you're going to be able to build and chat with other people who are on the server. So if I don't see the answer, or if somebody beats me to the answer, you'll get a faster response and from a wider audience than just with me in the comment section. Because some people have commented on other people on the YouTube channel on the video, but then it begins to really segregate, because it's not all in one place. You'd have to go to that video, scroll down to the comments, and then find it and respond. Where on Discord it is much more fluid, and we have several channels on the server, which I'm shocked that I have all these terminologies down now. I kind of creep my kids out a little bit. But all right, I over-programmed here a little bit and fell backwards into solving this. So sometimes you get lucky, sometimes you go from there, and sometimes this math is a little weird. But if you do it and you go through all the steps, because my goal was to basically to get down to 3 divided by 3 and have that be the remainder of 1. And I wanted to test that. I thought it was a little redundant, and I think it was, but it solved all the problems going forward. All right, sorry. I want to make sure that we didn't have anybody showing up, but I think everybody's finally left the house this morning, because it's been a weird morning, and we've gone from there. So let's see. All right. Anything else anybody wants to talk about? So I was looking at the power of 3, and so we got a solution that works, and it's pretty good. It got us in the top 10 percentile. Let's see. Let me check Discord. Am I unmuted? I'm not unmuted because I've started this stream like 15 times. Because first stream, the feed was a little low, and it was a little too slow, and YouTube wouldn't let it get started. So I stopped it, but then it showed up that it was there. Then the second stream, I think I streamed for like 10 minutes, and then the delivery guys were here early. So that was, I gotta fix this cord and make some slack. There we go. Okay. And then now this is the third attempt at this stream. So, all right. Finally, I'm unmuted on Discord. Don't see anything in. Let's come back over to chat. I definitely need a third monitor. Don't know where I'd put it. All right. But here's our solution for this. The stair step. I don't want it to come out here. So we could go back to that, or is there a Leetcode challenge that anybody wants me to look at and attack before I go back? Because I think I'm gonna go back to the stair step. Venky, are you pretty confident you have a solution for the stair step? Because I didn't have a chance to look at it, but I think you were articulating maybe a possible solution or the 100% solution, because you were very close on the power of 3. You were showing me divisible by 3, and then we just needed the extra little check if it went all the way down to 3, and then if it happened to be 1. So I wonder, see, part of me, because now I'm trying to spend time trying to think about optimization. Because if I do get a job more heavy as a programmer, and especially a data engineer, man, handling millions or billions of lines of code and data out of a table, these things multiple nested, because I feel like there's a way to speed this up. Since I have 2 else's, I feel well, it would never get to here. Now I want to try this, because that's redundant, right? Return none. Okay. Everybody see why? It never gets to here. So this has to be turned on. Oops. There we go. All right. You guys wanted me to go over none. Does everybody know what none just came out? Why none came out? How it is? Yeah. Okay. Thank you. I came across this problem one time. Don't know. I'm done. Not sure. Can you solve the product of 2 integers without using operators and it may be sum? Yeah. Step 1 equals step 1, 2. Step 3. Yeah. So see that's what, because that's where my brain was going. So if it's an even number, you're gonna have basically a counter of how many 2s. So, all right, but where you came across this problem one time, do you know? Can you send me the problem? Because I think we're kind of talking about 2 at one time. So I don't want to bore everybody and go back to the stair step problem. I may do that over the weekend when we have a new group and nobody wants to gouge their eyes out watching me do the same problem again, because I think I frustrated a lot of people when I stayed with the parentheses problem for too long. So I don't want to do that. I don't want to bore you guys. But tell me, do you know what platform that problem was on? Where it says, so we need the product of 2 integers without using operators. Was there an example of the solution? So we can do that later. Let's go staircase. Okay, you want to do the staircase? Okay. If Venky wants to do staircase, we'll do the staircase. I'm not selling Venky out. Sorry about that, Venky. I want to do the staircase. All right. Oh, and also I'm trying to watch my sugar. So I'm getting older and I'm getting chubbier. So I did really good. Yes. Oh, and I'm an addict. So I have to watch. I can get addicted to anything. Insert anything. So one of my latest problems right now is sugar. So I've tried to cut out a bunch of other things, and sugar has ended up being my replacement addiction. Oh, cool! I think I just accidentally fell backwards into solving. So yesterday, I just ate a bunch of protein. I had my 2 Gatorades. They have a bunch of electrolytes, so that's just not raw sugar, because there's a caffeinated drink in the U.S. That I just absolutely love, and I could sit and drink for hours. And it's just full of the worst sugar, the high fructose corn syrup. But I mean, it's so good. So I've tried to do it in moderation, and when I have one, I have 14. So I can't do anything. I can't do anything in moderation. All right. I digress. Maybe electrolytes would be good. Yeah. So I drink a Gatorade in the morning, a Gatorade at night to stay hydrated, and that makes me feel good. And then water, dash of lemon juice. You know what? My daughter's been getting up in the morning and squeezing fresh lemons and drinking that. And she says that she loves that because she's trying to find something to drink in the morning that she really likes. And because she's very young and a very healthy person, and she's trying to build her good habits now. So I'm trying to mimic that as I'm upping my activities, but my food is still awful. So yesterday I just drank a bunch of my protein drinks. I had a small lunch and then a big dinner. And I know it's not one day, but I cut out my sugary dessert at night. As like I said, I got a problem. All right. I digress. I don't want to bore everybody into tears. So, all right. So Vinky and I, we are very interested in this stair step problem. So I know what to do. So this is a perfect example of human brain. And so here's your visualization. So if you do not see this problem, here, let me add this. Leetcode, power of 3 solution, optimization, and stair step problem. Let's get rid of optimization because I'm running out of. Sorry, I'm retyping. And stair step problem. Let me see if I can find what Leetcode that was so we can have it in Leetcode, because I have 14 letters that I can reuse, and I got 15 letters I can use. Stair step, let me go back one. Leetcode. Duplicate tabs. Leetcode is a pretty user-friendly. I hate that it doesn't default to. I guess here I am judging stairs. Stair. Climbing stairs. Was that it? Climbing stairs. Yes, climbing stairs. Number 70. All right, and stair step problem. Number 70. We'll just do Leetcode. Code 70. Perfect. And stair step Leetcode. Awesome. Save. There we are. Okay, sorry I was doing that off. I'm just trying to make the heading, the title of the streams and videos proper. All right. So if you go and look at Leetcode problem 70, what it is if you have, so we have 1, 2, 3, 4, 5, 6. What are all of the combinations you can go through to get to cover these 6 steps? So Vinky and I were a little bit ahead of everybody. 1, 2, 3, 4, 5, 6. All right. So in this solution, you have, so here's the base case. Now you can rearrange all of, so not only do you have these basic structures, then you can mix and match these. So these two are set. Anytime, any rearrange of all ones or all twos, you're gonna, the order in which you could take these. But now these two are different. You could take one step, then a two step, then a one step, then a two step. So we go 1, 2, 1, 2. That makes sense? So then, or you could do the first one, 1, 1, 2, 2, 2, like this origination, 1, 1, 2, 2. Or then, what's the next combination? That would be 2. That's a bad 2. 2, 1, 1, 2. You follow me? And boom. All right, so back to here. And then the last one, I believe, no, there's several more. Because now I moved this, see how I moved this 2 through? So here's a weird thing. So my dyslexia and ADHD, huge negatives that I have, huge negatives. But there's some really goofy and weird positives. I can literally watch this 2 move through here. And I can, or if you see this as a diagonal, you see this here. So then now the next one, as how about we start this over, and I'll show you what I'm talking about with moving this through here. Let's do this again. Let's start up here. This one up here, and I think there's 6 combinations. So I'm going to go 1, 1, 2, 2, 1, 2, 1, 2, 2, 1, 1, 2. See how this 2 moved through? I moved it all the way through. So now we're going to move this 2 all the way through. 2, 1, 2, 1, and 2, 2, 1, 1. These are all the combinations from this base case. So in this combination, there's literally 1, 2, 3, 4, 5. There's 5 variations of this. And then now there's going to be 6. So I think there's a mathematical formula here, Venki, that you and I are missing. So once we do the math of this, because I want to see if I can figure this out. So I believe it's base. So if we can get here, there is 2 2s and 2 1s. 1, 2, 3, 4, 5. That's not what I was expecting. So so there's only one combination for the 3. One combination for the 3. So then as I come through here, and all right, let's clean this up. Back to brush, 1, 5. Let's come out here and let's see. And this is 1. All right. So we have 1, 1, 1, 1, 2. Then we're just going to move the 2 all the way through. Is that right? 1, 2, 3, 4, 5. Also 5. That is not what I was expecting. because each of these could be a 1 or a 2. I know what I'm thinking about, because no, we can't have duplicates, can we? Because then if I change the order, of this, hang on, let me make sure I didn't miss an important text or something. I don't think so. Nope. All right. Sorry about that. All right. So here we are. So, because what I was looking at is something along the lines of each one could either be the 1 or a 2. But so 1, 2, 3, 4, 5. All right. Because we need to get each of these, and then we need to scramble them. I think first step is maybe get this right. Is get this set up. Let's do that. That makes me feel better. So I missed one, Vinky. Okay, that makes me feel a lot better. So this is 5. I guess I thought that would be, there'd be more because we have more numbers, because we have 4 numbers here. So we have 3, and we have 6, then we have 4, and we have 5. But all right, Vinky's saying that I missed one for this combination. So let's go back. All right, Vinky, and I trust you. Vinky's fixed my math a couple times before, and my logic. All right, so 1, 2, 1, 2, 2, 1, 1, 2, 2, 1, 2, 1, and 2, 2, 1, 1. 1, 2, 3, 4, 5, 6. All right. So Vinky says there's. Let's go back. Put them side by side. 1, 1, 2, 2. Then 1, 2, 1, 2. 2, 1, 1, 2. 1, 2, 3, 4, 5. And mine. All right, let's go back over. Oh, that's outstanding. Yes, Vinky, that is great. Okay. That actually makes me feel a lot more sane. Okay. And Vinky is correct. So every time through, let's go back. Let's set this back up. I missed an entire combination. All right, 1, 1, 2, 2. So through every spot, I needed to move both 2s. So let's go back. So now I was not thinking about these dials. There we go. So then I need to go 2, 1, 1, 2, then 2, 1, 2, 1, and 2, 2, 1, 1. 1, 2, 3, 4, 5, 6. There we go. That makes me feel a lot better. All right, so let's get rid of all of this. That may solve a lot of our problems of the other day, Vinky. Because I was very shocked. So that seemed... Alright. So now we're at... This one is... What is that? 6, 12. So we're at 13. So total of 13 combinations. Gee whiz. Of how we can go up these stairs. Now we need to get this. One, we need to get this in a list. Let's see if we can do this right now to get this in a list. I may need... Alright, how long have we been on? We've been on... Well, if we add up all the time, we've probably been on well over an hour. But alright. That is some bad lighting. Hang on. My watch is telling me I'm lazy and I need to get up and move around. Let me do this, then this. Let's get this to work for an even number for stairs. Is that a built-in word? All right. All right, Vinky. Have you got something to build the reaching to step 7 either from step 6 or step 5? Reaching to step 7 either from step 6 or 5. Vinky, sorry, not following you. Let's get this to print combo 6. So we need, let's just get this to print out. Let's pass. All right. Get out the ones. Okay. So first we need a base is a blank list. All right. So then singles. Single equals a list of 1 times n. Then base dot append. I know this is awful. Do not hold me to this. Base dot append singles. We got to get this. I got to get this to work and get this out of my brain, because this is driving me bananas. All right, so okay, print none. Huh. Didn't create it again. Let's see, Vinky. We are allowed to take either 1 or 2 steps at a time. So possible move step 7. Oh, yes. But I guess I want to get this to work. We just need to get this to get to this right here, and then we need to take the largest number or do we want to get, because we've got to solve this problem of how many of combinations of 2, or is it going to be very similar where we just take this divided by 2 divided by 2 divided by 2, and then if it's a remainder of 1, That's our biggest case. What do we think about that? We take our in. Yeah. Everybody follow me on that? So instead of trying to get fancy, all right, instead of trying to get fancy, we're going to take our in stairs, divide by 2, append to our, and then after we get our largest, so let's say we have our largest one right here, and it's 6. So we have 2, 2, 2. This is our smallest number of steps we can take to get to our in. Ha! Here we go. This is the smallest number of steps, and then then our goal is, what is the next smallest number of steps? Well, if it has a 2, we're going to divide it by Yep. Everybody following me? And this is going to do this while it has a 2. Everybody follow that. I know that's in my brain, and I know that sounds super weird. So if it is a 2, it's going to break it into one step. If it's a 1, it's just going to put it back in the list. All right. Bear with me with this, and we'll go from there. And then this should work on combos. Just we're going to call this stairs because I got to call this combos. Stairs. Stairs. And then base. And then combos. All right. So that was dumb. Let's see. Iter-tools, combinations, or product. I was going to check the whole combination. Yeah, check combinations. I could not get that to work last time, which I have a very strong feeling that this challenge was designed and you're going to get a flaw. So it's basically, don't forget that Leetcode is going to exploit problems with that. So yes, and it's also, it wants us to do this longhand too. So even if it's going to work most of the time, there's probably going to be a flaw in there and it's going to exploit it. So we need to learn how to do this the longhand way, because I promise you in real life, you're going to have something that's really close to this. So let's just get to it. So let's see. If this works on 6, what do we do? So while in so n is going to be 6. We're going to set this up. So n divided by 2. Not divided by 2, minus 2. Minus 2, minus 2, minus 2. While in greater than 1, n minus equals 1, no, 2, minus 2, then combo dot append then once that happens, if n equals, so we're going to move this over. So bear with me right now because we need to get this to work on the fewest number, and then we can just go from there and break this out. All right. And then there's probably a more efficient way to do this, but I think we can solve this. What actual time is it? All right. Doing good right here. All right. If n equals 1, then combo dot append combo 1, then base dot combo dot append combo. All right, let's see what this looks like. All right, that's not what I was expecting. All right, let's do our old famous print 2s. Why isn't this? So that means none of my 2s are happening. Right. So then where is this? Print in. Let's do print in. Print in. Nothing. And they're all printing here. But n is supposed to be... All right. I'm here. Combo. Return the base. Let's change this up. No. See what I'm missing. While n is greater than, I'm not even getting, I'm not hitting this at all. Is this first time through? What am I missing? Anybody seeing what I'm missing? Because this first time through, n is 6. Passing in n, let me make sure. All right. I'm appending I don't feel like that's it, but that's also wrong. Because I was appending a list to the combo. Then base here. Let's flatten this out. N equals 6. Let's see what's going on here. Okay, that's what I was expecting. What was I missing? So now we have. So Vinky, now what I'm thinking is, since I have the smallest combinations here, well, one, I guess I need to figure out why in the world that wasn't working inside of because the combos are going to change every single time. So the base. So that's that one. Combo plus 2. No, that's what I was getting the issue into. I really want to figure out why in the world this wasn't working. Def stairs in, because this was bothering me, because we're going to have a problem here if I can't make this work inside. So in, taking in, and then calling stairs 6. Okay, that's weird. Return base. Why in the world? Doesn't matter. It's working now. If I spend too much time on this, I used to do this at work all the time. All right, so here now here's my smallest combination. Let's see if this works for 7. Because now I should get 3 2s. What? Built-in function or my object is not scriptable. Do what now? Built-in function or method is it saying that base is a keyword? And when I go 7, watch this throw up here. I've never seen it do this. And if 1, it is throwing up on line 9. Combo dot append and sloppy code, everybody. That's why. All right. So now here is the fewest. Here is the smallest number right here. That is the fastest way we can get up the stairs. All right. So this is now working. Venki, is this making sense? This is the fastest way, and of course then the slowest way, but all the combinations. So now we're going to go, what is the next fastest way? So now I'm going to take, all right. So now I want to look at, now we're going to iterate through, and again, this is the worst kind of brute forcey we're doing, because now we're going to go through here, and there's probably a math problem, and Venki's probably going bananas over this. So now we have our base, and we're going to look at base minus 1. All right. So then we're going to iterate for I in base minus 1. Then basically we're going to break that up. Does that make sense? If it's a 1, if it's a 1, here. if I equals 1, then print 1, else print 1 and 1. And okay, does that make sense? So we're going to need to exploit the extend. Oh boy. But now that I'm thinking about this, we can't iterate through the whole thing. So here's our dilemma, because we need to get to do this. Then we needed to get to do this. Split up each one of them. And then that's 6, right? Oh boy. Okay. So this is a humdinger. We're getting closer, but also farther apart. All right. Because we needed to do each one of these. All right. So how would we do? Let's come back over here. Not that. This. And try to cool some of the colors down. We're close. Probably driving some of y'all nuts that you probably already have the solution for this. Let's see how bad that white is. That's washing me out or making me a little bit yellow. All right. Let's see. We got some folks hanging out and bearing with us. No brush. Shortest number of steps. We'll just stick with our base case of 6. So we need one of these to happen. X equals base equals 2, 2, 2, close. So then I need, let's think about this. So the next one, base 2, is I need it to look like this. So I need to slice the base. If base -1 equals 1, what does pop do? Base dot pop. It removes. So basically every time I need to iterate through here, all right. We're gonna look a little bit into a list. Index. So we're gonna need to go forward. So we're going to utilize the tool. So now here's a little bit. So here's where we're going to merge logic and a little bit of Python work. So and let's work on this. So help on list dot index. So what does this do? Return index value of, it's basically going to be the first occurrence. So right now our base is what? So we're not going to look at the last one. We're going to do base dot index 2. First one. So then we're going to replace, let's see if this works. So base dot pop, and then let's look at help dot. I do not remember all the rules, so get in the habit and being comfortable. So right here, we may tweak this a little bit. We may use also X. If I do, and let's look at remove. So I'm not talking so much right now because I can feel my brain going 1,000 miles an hour trying to, bingo. So, all right. So we're not going to get too fancy with this. We could do some sort of combination or variation of, because pop is going to remove the last item. So if we go backwards, we're going to constantly need to be indexing through. But if we go forwards and we remove the first occurrence of 2, but we also get the index, so we're going to do some sort of, and basically as we go through this, we're going to insert two ones for every 2 that is still there. So for every time this occurs, now we just need to work on the functionality of, so base dot remove. So I don't know if it's going to be remove or index, and then also we need to work on the functionality of replacing. Let's start with index dot index 2 0. So now I want 2 2s dot extend base and base. All right, so I need, ooh, this may work. All right, so bear with me on this. So first variation, base underscore 1 equals this. Base underscore 1. Okay, so this doesn't make a copy of it, and it doesn't do it in place. So, all right, we need to look at help dot list dot extend. All right, extend list by appending elements from an iterable. I really thought that was going to work. So because if we go this way, I'm going to get the first occurrence. So if I use index, I'm going to get the first occurrence of the 2. And I really thought this. Let's try something. Singles equals 1 1. All right. That is not how. That doesn't look like singles to me. All right. So then singles dot extend base. I really thought this was going to work because that is a list. So we're going to need to keep let's redo singles. Okay, so yeah. Then singles dot extend base, and then singles again. All right. So now we're going to have a teeny tiny amount of an issue. Now I also want to try something. Inserting we may have to do this even more longhand. This is going to get really weird. Removes the index. Correct, yes. So we're going to remove it or slice it. So basically, yeah, I was just trying to, I was shocked. Yeah, Vinky, so you can know what I was going to do is basically I wanted to take the base, remove this, and then put this at the beginning of it. So what I think we're going to have to do is we're going to have to carve this out. And then basically index, put this in its place, then extend it. So I'm close. I see it in my brain. I don't know exactly, but yeah, I'm really very shocked because this would work perfect. And I'm really shocked this isn't working because this is a list. I mean, I'm absolutely shocked. I mean, that's a list. So, I mean, but it's not a variable, so it can't, it's not going. So I'm going to need to do something like this. So base. Oh, I actually want to try something. Is base still that? Perfect. So base. So if I find an index at 0, I want to go here all the way over. And then, but if I insert, if I do base 0, wait a second. No. Because then I'd be reassigning. All right. I see it in my brain because I want to move, but I should be able to extend. Well, this is a little frustrating. So I need to find the index. So if it's index 0, I need to do this. Combo would be equal to this plus base 1 combo. All right, so then if it's base, so then now I take combo and I append this to my base. Oh yeah. Here it is. And then that's my new So then now I'd have base equals, where are my 2 2s? Or my 3 2s? Oh man. There it is. Because I just appended that, my combination. Then I append this as a combination. That's my new base. And then base minus 1. Now I'm going to find my index of 2. So base index 1, excuse me, index 2, 0, 1, 2. So now let's look at something. So if you're just joining us, what we're doing is we're going through a stair step, finding all the variations of steps to go through this. So the shortest number of steps, the longest number of steps, and all combinations therein. So if you had 6 stairs, you would have 13 combinations of how to accomplish getting up to covering all 6 steps. And you can go through the variations. We had it right here. Shortest number of steps, longest number of steps. You can't really mix that variation. You can mix this 6 different ways, and then you can mix this 5 different ways. Vinky's been taking point on this and been helping out quite a bit. So now, if we can come up with an algorithm to derive this, so if this is index 2, I need the base, my base 1, here we go, base 1 through index 2 plus 1, 1 plus, I hate all these pluses, but I don't think there's a tool about this because there is no extend backwards because we just found an operator problem with a non, all right, hang on. So that's that. Then base negative, no, this is wrong. Hang on. Negative 1. So this is. All right, negative 1. Close that out. And then negative 3 on. So we're here. This is only while, and then 3 on. All right, everybody see what I did there? So we're really close. And we need to put a condition on this because we don't want to over-index. So now I took the base, I moved it over 1. So I think this is our first. Because also the way that we're doing this, our 2 will always be in the front. So yeah, we're going to index through and come through and come through and come through. And then the last one, we're going to do, let's see, where are we? Yep. Then we need to base dot append this. And all this is going to be dynamic. So then base. So here we are. You see how we're doing this? 2 steps here. And then, of course, we're not even done. We have to then mix all these. That's going to be a whole other issue. I don't know if we can do this another day. Everybody will probably go nuts. They're like, why are we doing this again? But once I get on these things, whoa, sorry, old coworker. She just sent me something cool. So all right, so now Now we need to do this again. So I need to find index 4. So now I'm looking at this. And this is how we can handle it if there is no, we're going to put a caveat. If this fails, we'll do that in a minute. And this will be whatever this is. So now we're going to take this and this is going to crash. So because we need to put a caveat here. So -1. So we need to make this dynamic. Because this will be at the end. All right, let's get rid of this. So if this is 4, and then also this is how we're going to protect against this. Len of base -1. So why do I care about this? Aha. So while this is, every time we do this, if this is less than the len, because we're finding this last argument, so we're going to need to adjust this every so often. Venki, are you on Discord? Because I have a feeling we're going to do this for just a little bit longer, and then I will send this solution that I find over to Discord, or you send it to me first, and we'll compare and contrast. Because I think we're losing everybody pretty quickly. I think everybody's eyes are glossing over, and I don't want to ruin everybody's attention. So let's see, and I think the color is getting bad too. All right, let's see. Removes the index. Oh, I think that's an old. So now if this is the case, this means this is going to be. All right, awesome. Okay, I only want to stick with this if you're still here. If you drop or you have to go, just let me know and I'll probably wrap up. All right, so we're getting close. We're at least getting all these base cases, and we can figure out a way to make this dynamic. So now we need to watch this. So this will be our last, because we need to do this test, because we need to know when we're at the end. So since this is the last one, and it's at the last element of the last combination. So then it'll be something like this. Base. So it'd be base -1 -1 and through 4 and close that out. Let's make sure. Bingo. And then plus 1 1 1. That makes sense. So then now I do base dot append this. And we can figure out a way to make this all dynamic, and then we'll probably stop for here. So then now I have all my base cases. For I in base print I. Bingo. So here we are. Shortest to longest. Now let's get this to do this in an algorithm. And then we'll stop here. So we'll get to this, and then I think if I build this, then you should be able to come in here, and I think then we can do combinations of mixing and matching, because this can only be, I know there's some math here. That can only be 1. That can only be 1. So we have feel like there's a 2 to the power of the length. I don't know. And then some sort of oh boy. Sorry, guys. My wife got some work news yesterday, so we may both be unemployed. So there we go. Yeah. Her boss, he struggles with uncomfortable conversations. He avoids them at all cost. Which, I mean, I remember that. I didn't like him either. So if we have, well, yeah. All right, let's get to here, and I will let you math geniuses solve this. But we need to at least find a way to build this base case. Shortest to longest and everything in between. All right. So we have our base happening here, where we get this. So we do not need this to be printed out. All right, so we need to think about this. So we need now to take the 2's. So after this, now we need to come through here and try. Reason why I'm going to go with try is base. So if I do base index 0, excuse me, index 0, index 2, I get 0. First occurrence of 2's. Now if I do base minus 1, minus 1, 2 is not on the list. So try, then base index 0, index 2, right? Let's see. Did not hear a noise on, let's see. Oh, I think in a seashell just sent me something. And whoa, you got it all to mix up? Nice. Those are all the combinations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Was that it? So you have it going through and mixing and matching. All right, that is very cool. Don't send the code yet. So you're done and already ahead of me. That is so cool. Just a question. I think it's just the 3 of us right now. Are you doing that? You're doing that as you're adding the 2's. Vinky, is that you in a seashell? Is that you on Discord? Because that is the one thing, is that some folks have mixed and matched non-consistent names across the board. So all right, I can't tell if Did I just stop the stream? Yep, that is you. That's awesome. Okay. Well, you're ahead of me. Well, I may just, it looks like it's just me and you. Except, what is it? Value, accept value error. Accept value error. Return base. All right. Well, you're already done. So do you want to even see how I do this? Because now, can you try it for 7 and see if you get it to work, and then run it through Leetcode and see if we're even getting close. And then also, do you have a caveat for any negative stairs? Because be prepared for that. All right. So try -2. So that is so cool. I'll reach out to you and see if I finally solve this, because yeah, it looks like I may need to be going here in a few minutes and get some stuff. I need to get the oven installed and go from there. But all right, let me see if I can at least get this to be built, and then I'll go through again. Yeah, that does seem not good. Did you do it with itertools? Is that how you did it, or did you do it longhand? Because either way, getting it to work is great. Okay, sorry about that. Let's see. Here we are. And one thing that's very interesting to me is once I hit 1 million subscribers, my channel has been acting really weird. The impressions have gone down. Subscriber growth has gone down. It's been really, really, really weird. All right, so let me go back and check this out up here. So if let's do 1 and let's see what happens. I had it go through with itertools, but kept bugging. Instead, I used one global variable, mostly similar to your code. Okay, cool. Let's see what happens. 1 1. Okay. Why isn't? Did I really? I turned the speaker off. Is that the code? What? That's with 7. Nice. How many is that? Are you having it put into? Because I think what have that count. Have it count, and then do some longhand, and see what it says. Because have it check 13 for 6, and I know we've done 7, but I forgot what it was. But Vinky, that's awesome. Or seashell, however. But all right. Let me just check 3 and make sure that my base 21. Is that it? All right. Return none. Return none. That's not good. Because 2, did 2 work? Okay, that's not good. Well, n is greater than, that should have returned 2. That's not good at all. So 1. Why isn't 2 returning a step of 2? Combination of 2. Returning none, returning none, returning none. Alright, so if it's 2, greater than 2, greater than 1, n minus 1, append combo 2, then combo append base, oh, return base. There we go. Alright, cool. So now if an index is there, -1. Ah. So combo equals, so I'm back to, I need to reset to an empty base. You're probably doing this a lot cleaner than I, Vinky. Alright, so what was our first iteration? So I'm going to have so what would it look like? Base equals, Vinky's probably laughing and be like, why is he doing this such the long way? Alright. So then base index 2, 0. Alright. And then we also need to check if the len of base equals 1. So then basically while yeah. Okay. While len, here we go. While len base minus so I need to reset this true. Would this catch, let's see something. Let's see. I'm maybe a little too distracted to finish this. I'm getting some more text. Alright. So I'm trying to figure out, and Vinky's already solved this. Vinky's always one step ahead of me. Because we looked at the algorithm that we decided, and we saw something along these lines. So we have the base, which gets us to here. So we did have a caveat of an issue. Index 0, so it's greater than or equal to. So all right, let's try something. So we're going to get it to stop before I over-engineer this. Vinky's like, you're making it harder than it needs to be, which I get. I do that a lot. And what does 3 need to be? Let's check if I'm getting. All right, so 2 and 1. So I want this to do this at least one time through to check here. So if this is wait a minute. Yeah. While if it's here, is index a keyword? Nope. While index Okay. Sorry, everybody. Lots of drama. Things are changing at my wife's work. She's only been there about a year, and things have slowed down quite a bit. So she got a little bit of news yesterday. It's all right. While index is less than, we're just going to do while true. All right. I don't know if I responded to that. Okay. All right. I'll try to get this piece done, and then I'm probably going to drop, and then I need to start wiring up the oven and wait for one of my kids to come home and help me load it up. Comment, just return base. Comment out the try. So how are you handling? Well, the way I have this set up, hear me out, Vinky. I agree. Comment the try, accept. Just return base. So what? But if I think the way you're doing it is, again, more efficient, but I'm checking then the last one. So if I have let's see. So I'm going to take, and like I said, yours is probably cleaner because you did this each time through and built it. So I can see what you did is you had a 2, and then if you had a 2, oh, so you iterated. Aha, I see how you did it. So you basically checked, can I go 1 step? And then you checked, can I do 2 steps? Then you did 2 steps. Is that how you did it? And then you went, if I can go 1 step, 2 step, 3 step. Oh, I see what you did. I like that too. I'm going to see if I can do that. So basically you went 1, 2, then 2, then 1, 2, 3, then 1, 2, 3. Then you went 1, 2, 3, 4, 2, 4, 1, 2, 4. Is that how you wrote it? Because I think if you did that, then you wouldn't need the try except. I'm coming in here, and yes, I don't think you're doing it my way, because if I had this, and if I did an index on, let's see, where am I on base? And let me add, let me comment this out. So to show you, let's just do x equals, there we go. So if I try to find index of 2, then I'm going to get a value error. Indubitably. Hey, that's great. I love that. It is probably, but see, I have to have the try and except if I'm going to do this, which my brain does this. I see how you did it. I can't do that. I can't see that. And I'm looking at the time here. It's heading towards mid-morning. So I'm going to work on this. I'll let you know if I get it done. I would love to see your code. But yeah, I love how you're doing it. You're moving through each variation and each step, and that's so cool. I absolutely love it. But all right, it's just me and you hanging out right now. I appreciate you coming to spend time with me. And don't know what we're gonna do tomorrow, but we'll pick back up, and we'll have an awesome time. All right. Thanks, Vinky. See you later.